Okay, so today's lesson is over what is called identifying rational numbers. And we have talked about rational numbers and used some examples of them like fractions and decimals. Today's lesson is not so much going to be math. It's going to be a lot of putting into groups and identifying. It's going to be a little different type of lesson than what we're used to. There are going to be several vocab words that we have to get down. So these first three, you want to make sure that you've got down a rational number, a terminating decimal, and a repeating decimal. So go ahead and pause your video right now and get these down. Okay, so a rational number is any whole number, a terminating decimal, or a repeating decimal. And what also goes along with a terminating and a repeating decimal would be also any fractions. And these can all be positive or negative. And the reason why fractions are included is another thing about rational numbers that is true. And this is like the deciding factor between if it is a rational number and if it is not a rational number, is rational numbers can be written as a fraction. It can be written as a fraction. So if a number can be written as a fraction, then it would be a rational number. So something like 3 is really 3 over 1. We can write that as a fraction. And so that would be a rational number. And then like we've talked about already, with turning decimals into fractions, something like 1.25, well, that is 1 1/4. We can write that number as a fraction. So 1.25 is a rational number. Okay, so rational numbers can be written as a fraction. And then terminating and repeating decimal. Terminating decimals end with a 0 or they just end. They stop at some point. And then repeating decimals that have a number or a series of numbers that continue to repeat. Okay, so we've got 3 more as well that go along with this. A whole number, a natural number, and an irrational number. So go ahead and get those 3 down. Pause your video. Okay, so a whole number is any positive integer. Remember, integers are any number that's not a fraction or a decimal. So whole numbers, they're the counting numbers. They're all the numbers you learn whenever you first start to count. 1, 2, 3, 4, 5. Remember these 3 dots here in the whole numbers means that it continues to go on forever and it doesn't end. Notice there's only one difference between a whole number and a natural number, and that is 0. Natural numbers include 0 and then everything after that, which is positive. Whole numbers do not include 0. Because if you have 0, you have nothing. You do not have a whole of anything. Okay, so whole numbers, natural numbers, basically the same. Natural numbers include 0. And then an irrational number, any number that is not rational. So decimals that never end and they never repeat. Another thing about irrational numbers is you cannot write them as a fraction. So irrational numbers, they are the opposite of rational. And irrational numbers, like I said, you cannot write them as fractions. They are decimals. We're going to talk about a few examples here in a second. The decimals that they will never end and repeat. So there's no rhyme or reason. There's no pattern to them. They continue on forever, but there's nothing you can say as far as repeating any part of it. Okay, so those are your vocab words. So now at the bottom half of your paper, if you notice, you've got a big spot that's left open. I want you to copy down this chart. And then we're going to fill in a few things about them as well and talk about how it works. So pause your video and get this chart down. Okay, so we're going to fill in some numbers here. Now, first of all, I want you to notice up at the very top, this is called the real numbers. So the real numbers are everything. Okay, everything that we will ever work with are called real numbers. And so make sure that you understand that both rational numbers and irrational numbers are all what we call real numbers. So then we're going to use this to group everything as well. First of all, let's start in the very center. So the very middle circle here on the rational number side is the whole numbers. Whole numbers are 1 and everything after that. So we'll put a few examples there. 7 is a whole number. 13 is a whole number. 2004, that's a whole number. So whole numbers, positive integers. Okay, natural numbers. So notice that the whole number circle is inside of the natural number circle. So every whole number is also a natural number, but not every natural number is a whole number. Okay, now there is only one natural number that cannot go inside of the whole numbers circle. See if you think you know what it is. The only one that cannot go inside is 0. So 0 is going to be inside the natural number circle, but outside of whole numbers. Everything else, 1, 2, 3, 4, and continues on, is also inside of whole numbers. Okay. So now let's move one step out to integers. Integers contain all the natural numbers, which is 0, 1, 2, 3, 4, and so on and so forth. But integers are also negative. So remember, integers are not fractions and they are not decimals, but they're everything else. So all of your negative integers will go outside of the natural numbers, but inside of the integers. Something like -3. That's not a natural number because it's a negative number, but it's still an integer. Something like -1000. That is an integer. Or maybe -23. That is an integer as well. Okay? So all the negative numbers, all the negative integers will not go inside of natural numbers. But then everything that's inside of natural numbers, everything that's inside of whole numbers is also inside of integers. You see how those circles are all inside there? Okay, and then finally, rational numbers. Now, everything that we've written down so far, all the integers, natural numbers, whole numbers, those are all rational numbers. Okay, they fit inside of there. But there are also certain rational numbers that are not integers. Remember, we said there are two types of numbers that integers are not. Integers are not fractions. So 4/5, that is a rational number, but that is not an integer. Okay, what about a negative fraction like -3 2/7? That is a rational number, but it is not an integer. So it's got to go outside of the integers. So a couple others. We also said there are terminating decimals like 2.5. Okay, that is a rational number. It's not an integer though because it's a decimal. And then -0.6 repeating. That is a rational number, but that is not an integer. Okay, so looking at this chart, I want you to look at yours as well. So every integer is a rational number because the entire integer circle is inside of rational numbers. But every rational number is not an integer. And we can say the same thing. So if a number is a whole number, whole numbers are also natural numbers, they are integers, and they are rational numbers. If a number is an integer, it is definitely a rational number, but we'll have to look at that number to see if it's a natural number or a whole number. So we're going to be using this chart a lot today. Okay, irrational numbers on the other side of our chart. We'll go through a couple of them, and we're going to come back and write down one more thing at this chart at the very end. Okay, but irrational numbers. There is one number that you all are familiar with that never ends. It's a decimal that never ends and it never repeats. It is a number that you use in geometry as well. And that is pi. Pi is a decimal, but nothing ever repeats and it never ends. You all probably know that. So pi is an irrational number. There is another common irrational number, and that is the square root of 2. And we're going to talk here in a second why the square root of 2 is an irrational number. Okay, but those are two common ones. We'll come back at the very end and talk about one more type of number that's irrational. So this chart, if it's an irrational number, it's just irrational. There's nothing else to it. If it's a rational number, then you need to look to see, okay, it's a fraction, it's a decimal, it's an integer, and then see where it goes from there. Okay, so what we're going to be doing today is listing the sets of numbers that these belong to. So our first one is we have 0.25 repeating. So you might want to go back to your chart. Where are all of our decimals located? All of our decimals are located in the natural numbers. It's a repeating decimal, so this would be a rational number. So then going down one more, is this an integer? Well, no, it is not an integer because remember, integers cannot be decimals, okay? So a rational number is the only thing it belongs to. Okay, what about the negative square root of 36? One thing that I would suggest doing is look to see if you can simplify this. So if you see a fraction or a square root, look to see if you can simplify. The square root of 36 is 6. And so this is negative 6. So now let's go back and look at where negative 6 would fall. Well, negative 6 would be an integer. So if a number is an integer, it is also a rational number because every integer is inside of the rational number. So integer and rational number. Then let's keep going down. Is negative 6 a natural number? And it's not a natural number because it's negative. Remember, natural numbers are 0 and above. So it cannot be a whole number either. Okay, so integer and rational would be negative 6 or negative square root of 36. And then finally, pi. We already said pi is a decimal that never ends and never repeats. So it would be an irrational number. Right, so those are our 3 examples. I want you all to look at these 3 and see if you can name all of the sets that those 3 numbers belong to. Pause your video and answer those. Okay, so 2 4/5. 2 4/5 is a fraction. Remember, if it can be written as a fraction, it is a rational number. Is 2 4/5 also going to be an integer? Well, no, it can't, because remember we said integers are not fractions. So this would just be a rational number. Okay, I want to skip square root of 50, and let's look at 81 over 9 first. Can we simplify 81 over 9? The answer is yes, we can. 81 over 9 simplifies to 9. So now go back and look and see where 9 would fall. 9 would be rational, okay? It would actually be a whole number, correct? Because a positive integer is a whole number. So if 9 is a whole number, it is, look at where whole numbers is inside of. Whole numbers, they're inside of natural numbers, they're inside of integers, and they're inside of rational numbers. So the 9 is a whole number, a natural number. We've got to list all of them. It is an integer, and it is a rational number. So all 4 of those would be 9. So any whole number is also going to be natural, integer, and rational. Okay, let's look at the square root of 50. Remember, the square root is what number times itself equals 50. Thinking about it, there is no number times itself that would give us 50. 7 times 7 is 49, and 8 times 8 is 64. So 50 kind of falls in between those. So the square root of 50, it doesn't have a number that we can find. In fact, if you were to type this into a calculator, you would get a bunch of decimals, and it would never end, and it would never repeat. And so if you can't find the square root of a number, then that means it is irrational. So go ahead and get that down, that it's an irrational number. And then once you've got that down, flip back over to your chart at the other page. There's one other thing I want to add to irrational numbers, and that is this. The square root of any non-perfect squares. And I'm getting ready to explain what a non-perfect square is. And this means basically, if you can't find the square root of this number, it's probably an irrational number. And so a couple of examples. The square root of 7. We don't know what that is. That's an irrational number. The square root of 50. Or the square root of 38. Okay, those are 3 examples of square roots that are all going to be irrational. So to explain what a non-perfect square is, look at these 2 problems. So the first one, what do you notice about the square root of 1, 4, 9, 16, and 25? What's the square root of 1? What number times itself equals 1? Well, that would be 1. The square root of 4, what number times itself equals 4? That would be 2. The square root of 9 is 3. 3 times 3 equals 9. The square root of 16 is 4. 4 times 4 equals 16. The square root of 25 is 5. We can continue on. But all of these numbers, we call them perfect squares. And perfect squares are 1, 4, 9, 16, 25. They are all rational. So a perfect square is a number that you can find the square root of. So a perfect square would be 1, 4, 9, 16, 25. 6 times 6 is 36. 7 times 7 is 49. 64, 81, 10 times 10 is 100. So continuing on, you can go on as far as you want. Those are all what we call perfect squares. Notice, do we know what the square root of 2 is? The square root of 7 or 20 or 35? We don't. So we call these non-perfect squares. And non-perfect squares, remember, are irrational. So the square root of 2 is irrational, 7, the square root of 20, those are all irrational because we don't know what those are. Okay, we can't just find those without a calculator, so that means they're going to be an irrational number. So I would keep that chart out as you work on some of these practice problems because that's going to help you be able to figure out where all of these numbers fall. Because today, most of it, what you're going to be doing is just listing all the sets that a number belongs to. Okay, so these pages, IN20, IN21, IN22, they are near the back of your book. So if you flip to the back, it's right around the 330, 340, around those pages, you'll find the section of IN numbers, and that is the pages you're going to be working on today. So go ahead and work on those.